Okay, guys. So let's start the session. So in the last class, we have discussed about the probability. We have discussed the probability and along with that probability distributions. What is meant by probability distribution, right? And within the probability distribution, we have seen with respect to one continuous and discrete probability distribution and continuous probability distribution, right? If you're applying on the continuous variable, it is called as continuous probability distribution. If you're applying on the discrete variable, discrete probability distribution. For a discrete variables, for example, let us take like males and females. And what is the probability of males you are having? What is the probability of female you are having? The probability of male is 0.7 and probability of females is 0.3. Just you are taking some kind of probability on the y-axis. On the x-axis, you are going with respect to the discrete variable. Similarly, if you are continuous variable, for example, you are taking from 0 to 10, how many students are there? From 10 to 20, how many students are there? 20 to 30, how many students are there? And you are just applying the probabilities. You are calculating the probability for each of them and you are representing the bar. Like this, you are representing the entire bar. Then it is called as probability distribution. For example, this is 0 0.2, 0 0.3, 0 0.15, 0 0.1, and 0.565. Sorry, 75, something like if you want, you can take this one as 0.3, 0.4, 0.25, 0.15. Now 3 plus 4, 7. The total should be 1. The sum of the probabilities is equal to 1. So whatever the continuous variable you are considering, any variable, the probability is always going to be the 1. So in the last class, this is the example which we have taken. So in this case, just we have counted first. That is here total number of students from 90 to 100. How many students are there? Means 5 students are there. From 100 to this one, 6 students are there. 4, 3 and 2. This is with respect to their count. You are representing the frequency distribution. This is called as frequency because on the y-axis you are having the frequency and on the x-axis you are having the distribution of the data, which is continuous data. So this is with respect to continuous frequency distribution. This particular chart, whatever you are saying, it is a continuous frequency distribution. Now this same thing, if you are converting to probability, probability means nothing but for each of them you are calculating the respective probabilities. 5 by 20, 6 by 20, 4 by 20, 3 by 20 and 2 by 20. Now these are the respective probabilities. Now if you are having this one on the y-axis, you are having the probability. On the x-axis, you are having the continuous variable. So this is called as probability distribution. This is called as frequency distribution. Left side frequency distribution, right side is the probability distribution, continuous probability distribution. Now if you see here, the sum of the probabilities is equal to 1. For example, let us take total 20 students are there. Okay, total 20 students are there. Out of which from 90 to 100, I am having 10 students are there. Assume 10 students are there. From 100 to 110, you are having 8 students. From 110 to 120, 0 students. From 120 to 130, 2 students are there. Right? Out of 20, these are the things. Now you are calculating the probability. What is the probability of 90 to 100? That is 10 by 20, which is nothing but 0.5. You are going to collect as 0.5. Next, 8 by 20. 8 by 20 is nothing but 0.4. You are going to take as 0.4. Next, this one as 0. No, nothing will be there. This one as 0.1. Whatever the probability is there, that same probability you are representing here. If the probability is in the whatever the order, you are having whatever the order, just you are going to take the probabilities on the y-axis and representing on the continuous variable on the x-axis. From 110 to 120, 0 are there. So 0 bar. 130 to this one, 0.1 up to height of 0.1. The same thing you are representing here with respect to the probabilities. Right? Now this is whatever the value you are having, just you are representing, which is called as probability distribution. Every time the total of the probability is going to be 1 because here the number of values, if you use the number of values, you are going to divide by total only. Both will be always same now, 20 by 20 only. For example, if the probability is different, for example, let us take like this. You are having from 90 to 100, you are having 4 students. You are having 12 students. You are having 2 students. You are having this one also 2 students. Now, again, it is 20 by 20 only, right? If you divide by 20, divide by 20, divide by 20, The sum of the probabilities is nothing but 4 by 20 plus 12 by 20 plus 2 by 20 plus 2 by 20. Always 20 by 20. Sum is always equal to 1. Always the sum of the probabilities is equal to 1. Now, whatever the probability distribution is there, you can represent by using a bars like this, or the same thing you can show with respect to a curve like this. This also you can represent by using a curve like this, just by attaching all the endpoints. Okay, this is called as density curve. Now, what is meant by density? Density means nothing but mass by volume. Here, what is the mass means nothing but what is the probability. Volume is from here to here. In this particular area, how much mass is there means how much of probability is there, how much values are there. That it gives you the with respect to called as density curve. Density curve is nothing but combination combining the bars. You are combining the bars is called as density curve. Okay, whatever the bars you are having like this, just you are going to have the bars, you are going to combine like this. For this one, you are going to represent the same thing like this. For this one, you are going to represent like this. For this one, you are going to represent like this. For the same bars, you are just representing. Instead of indicating by bars, you are directly indicating by the curve. Curve and bars both are same. And what is the area under this one? What is the sum of the probabilities of the bars? 1. What is the total area under the curve? 1. This area 1, this area 1, this area also 1. Total area should be 1. Whatever is the type of curve. The curve is like this. For example, you are having a curve like this. That is also 1. Because the bar is, this one is of 0.5, this one of 0.2, and this one of with respect to 0.1. And like this, if you are having this, you are combining everything. Right? Whatever the values you are having, you are just combining. Always the entire area is always going to be the 1. Total area is nothing but sum of probabilities. Area means nothing but probabilities. The sum of the probabilities is equal to 1 for any kind of curve. For example, if you are having with respect to this one, a probability of 0.2. Next one is probability of 0.3. Next one is probability of 0.4 and probability of 0.1. Now, if you draw a curve, you are going to get a curve like this. This is the curve. What is the area? 1. Now, the same example I am writing first one with 0.9 and this one of 0.1. Now, if you are having a curve like this, now what is the area? Curve, though the curve was changed also, the area will remain always with respect to 1. If you are having with respect to one more example of 0.7, 0.2 and 0.1. Now, from here to here, if you add also, again 1. Area under the curve is always going to be the 1, whatever the area. For example, sir, for example, I'm having this one 0.2, sir, or 0.1. Okay, and I'm going to take 0.2. Next one with respect to 0.3. Next, there is a gap. Again, we are having with 0.2 here. Okay, now 0.7, 0.8, like this you are having. Now the curve, how you are going to get a curve? Like this you are going to get a curve. Here it is 0 now. Now if you combine the curve under the area under the curve, if you add everything, what is the probability? Again with respect to 1. So though here this particular bar only it is not having, but overall I am asking overall curve. The sum of the overall curve for every value. So for example, this is having certain probability, this is having certain probability for everyone, one probability is there. Now this probability is high and this probability is low. Probability is only low, but it is having some probability, and if you combine all of the probabilities, it is equal to 1. The same curve, if you write like this also, the area is going to be 1. Whatever the type of curve, the sum of the probabilities is equal to 1. Curve may be different based on the probabilities, but always the area is going to be total is 1. Now, if you are having the curve like this, it is called as uniform distribution. For example, I am going to bring from 1 to 100 numbers. 1 to 100 numbers. Tell me from 1 to 10, how many numbers will be there? 10 numbers. From 10 to 20, 10 numbers. From 10 to 20 to 30, 10. From 30 to 40, 10. From 30 to 40 to 50, 10. For everything the same bar only, na? Same height only. Na? For everything, it is the same height, same bar is there, means then it is called as uniform distribution. Then it is called as uniform distribution. Everything are same. Then it is called as uniform distribution. Example is from 1 to 100. If you take from 1 to 100 total number of values and all the values, total number of values, whatever you are having, that you are representing for each bar, you are having 10 values. Every bar will have the 10 values, equal distance, every height of 10. If you consider the probability, everything are 0.1, 0.1, 0.1, 10, 0.1 will be there. Total area is going to be 1 only. 0.1 plus 0.1 into 0.1 plus 0.1. Total area is always 1. Right? So uniform distribution means each bar is of on the same height. For example, here, let us consider there is a marks. Okay. Marks are with respect to the weights of the students. Whatever the earlier example is there. In my class, from the weights of the student from 50 to 60, 4 students are there. From 60 to 70 weight, 4 students are there. From 70 to 80, 4 students are there. From 80 to 90, 4 students are there. From 90 to 100 also, 4 students are there. Total 20 students are there in my class. Out of the weights are like this. Weight of the students in terms of kgs. Assume. Example. Total 20 students are there. And from 50 to 60, 4 students. And everyone are 4 students. Now, what is the probability of 50 to 60? What is the probability? 4 by 20. 4 by 20 is nothing but 0.2. So this is 0.2. This is 0.2, this is 0.2, this is 0.2, and this is 0.2. Sum of the probabilities is equal to 1, and the distribution will be like this. The height, so total 4 are there, 4 by 20, 0.2 is the probability. So this is called as uniform distribution. Uniform distribution means all of them are in the, all bars are on the same height. Then it is called as uniform distribution. Now, how to calculate the area in the uniform distribution? This is the question was given in the TCS exam. Whatever we are discussing today's class is completely of certification based questions. Okay, in real time, in the practical approach, we are not going to use these things. In the further machine learning or deep learning or artificial intelligence, we are not going to use all these things. But the strongness of the statistics to apply the fundamentals, you know the fundamentals, or if without knowing the fundamentals, you have came to check that one. They are checking in the certifications. In the certifications, this type of questions you can expect, right? Out of which the first one is for uniform distribution. You are having a uniform distribution. What proportion of values are located between 12.3 to 18.6? Uniform distribution, they are only saying that it is a uniform distribution and height of 0.05. Okay, now you are having from here to here 0.05, 0.05, 0.05 everywhere, right? Now, if you calculate with respect to this one, how to calculate the area? That area is nothing but, what is the question is, they want between 12.3 to 18.6. This is the area they want. How to calculate the area? Just area of the rectangle. You know the length, you know the breadth, L into B. Just you are multiplying with respect to this one, that is 18.6 to minus 12.3, you will get 6.3. Height of 0.05, which is equal to 31.5. So this is the area, this is the probability. Total number of people between 12.3 to 18.6 is 31.5. Is that clear? Sorry. Yeah, 0.315 is the probability. Percentage means 31.5 is the percentage. Probability value is 0.315. Let us explain with a simple example. I think you might be confused with respect to how you are considering this one. I will show you with the data set. So let us consider there are 20 students in my class. Earlier example, what I have told you, the 20 students, out of which 55 is student weight, first student weight. Second student weight is 57. Third student weight is 57. Fifth one is 56, 63, 64, 62, 69, 74, 78, 79. Why to consider 20? 10 only I will consider. It is mandated 20. Yeah? No. 4, 4, and this one. Stop here. But the Yeah. 56, 58, 62, 64, 72, 78, 84, 86, 92, 98. Two values. Everything two values I'm considering. Instead of considering everything four values, two values. Now, if you draw the probability distribution for this, what is the probability distribution? You are going to take from 50 to 60. How many students are there? 2 students out of 10. What is the probability? 0.2. So this is with respect to 0.2. From 60 to 70, how many students are there? 2 students are there. What is the probability? 0.2. And from this one, 70 to 80, how many students are there? 2 students are there. What is the probability? 0.2. From 80 to 90, 0.2. From 90 to 100, 0.2. This is a uniform distribution, right? This, whatever the data they have given to us, it is a uniform distribution. Now, I want from 70 to 90, how many students are there? Here, how many students are there from 70 to 90? 1, 2, 3, 4. 4 divided by 10, which is 0.4. This, now tell me, without seeing the data, they assume there is no data. Now, using the graph, you have to tell me how you are going to sell this area between 70 to 90. That is 70 minus 90. That is 20 into 0.2, which is 0.4. Got the point? The same answer. Now, let us change. Before changing, let me do the control Z. Otherwise, I can't get the values. Okay, 2 values missing. Okay, something. Now tell me, without seeing the data, from the graph, you tell me. From the graph, what is the probability of students from 75 to 85? From here to here. What is the probability? That is 75 minus 85, which is nothing but distance is 10. 10 into 0.2, which is 2. That is 2 students are there. So we are going to get 2 students only between 70 to 85, 75 to 85. So these are the 2 students. Satisfied? The condition satisfied? So just we are checking with respect to uniform distribution. Area can be calculated based on the simple rectangular formula. Easy. If the shape is uniform, we can apply the rectangular distribution. For example, if the shape is like this, in this case, we can't apply that concept. It is applicable only for the uniform distribution. The rectangular formula can be applied only for the uniform distribution because the area is like this. You want the area. So the area of the rectangle you can apply here. You can't apply the same concept here. In this case, you can't apply. If the shape is like this, you can't apply. If you are having the first bar is of height like this and second one is like this, again you can't apply. If it is having the rectangular shape within that, then you can apply. Inside that triangular shape is there or other shapes are there, means we can't apply. Right? Now, so just here, we are just applying the probability from here to here you want, miss just the distance into the height. Here they have not given the data also. By seeing the data directly, we can calculate the probability, but they have not given the data. The original data they have not given. Without giving the data, just they have given the diagram. From here, for anything from 0 to 20, the probability is of 0.05. It is a uniform distribution. How many of the students are having from 0 to 5, from 5 to 10, 10 to 15 also same number of people are there. Height is same. Since it is a uniform distribution, yes, they have given in the question only the uniform distribution diagram like this. This is the given question. For the uniform distribution below means the diagram also given. What proportion of values are located between 12.3 and 18.6? So this is the area they are asking from here to here. So the area is rectangular area. So you are going to apply the concept of area of rectangle for this. And you are calculating the probability. Right? Now, if you go with the second one, normal distribution. Uniform distribution is completed. Now the next one is normal distribution. What is meant by normal distribution? Which is a symmetrical distribution. I told you, right? Symmetrical distribution. Normal distribution is also called as symmetrical distribution. Non-symmetrical distribution is called as skewed distribution. Right? So now we are having a normal distribution like this. So normal distribution is also called as bell-shaped curve. It is a bell curve. So the shape of the distribution will be similar kind of bell, right? So we are having this kind of bell curve. So this is called as bell curve distribution, right? Now, whatever the probability distribution is there, what are the properties miss? Always it has to be on the x-axis only. So for example, can you tell me the probability, if some probability is there, you will get like this. Can you tell me any probability with negative value? Is the probability with negative value is possible? So bar can be down. If the bar is not down, then how you can get the graph also down? You can't get the curve also downside, right? Always the curve will be on the top of the x-axis only. Never it will come down, because the probability is not with respect to positive only. It can't be the negative. So always the curve will be on the x-axis, above the x-axis. Okay, it is not going to be the below the x-axis, or you can't write like this. This is not possible. This is not possible. This is also not possible, because you are going to take the values, the variable on the x-axis and the corresponding probabilities on the y-axis. So y-axis will have certain value of bar. Height of bar will be there. Based on the bar, curve will be there. How you can get the curve like this or curve like this? It is not possible. So this is the property of the density curve, one of the property. Of course, it is not going to be asked in the interview, or it is not going to be asked in the certification, nothing. Just basics, right? Now, and always the total area under the curve is equal to 1. This is the most favorite interview question for me. For every person in the statistics, I will ask what is the area under the curve. Okay. Now you are saying easily 1. After some time you will say the answer. After some time I am going to ask the interview question. At the time, remember this one. There is a link, right? So I'm going to ask some kind of interview questions. So the total area under the curve is equal to 1. Always the total area under the curve is equal to 1. Now, for a normal distribution, particularly for a normal distribution, you are going to have symmetrical distribution where it is having only one mode. The mode mean and median, everything are same. Mean, median, mode will be the same for the normal distribution. Already we have discussed during the symmetrical distribution and non-symmetrical distribution. If it is a symmetrical distribution, mean and median will be the same. If it is a left skewed, left skewed means automatically median will be here, mean will be here. So median is less than the mean. If it is a right skewed, obviously the median will be here. This is the median and center point will be the mean. So mean is greater than the median. So based on the skewness, we can draw the median value, in which the top bar is that is the median value, which mean will be always in the center location. Whereas for normal distribution, this is the mean and this is also the median. Everything will be the same. The top is this one only, na? So in the top position only the median will be there. So here only the median is there. In the entire data, this is the center point. So obviously mean also will be here only. Mean is equal to median. For the normal distribution, mean and median will be the same. And the curve is going to be the symmetrical. It is going to be the symmetrical from the mean. From the mean means from the center. From the center point, both of them are symmetrical. Right? Now, the particular normal distribution is characterized based on the mu and sigma. This is important. If it is a normal distribution, if it is forming a normal distribution, the normal distribution data can be characterized by mu and sigma. What is the meaning of that? Means, for example, any data, if it is following a normal distribution, assume it is following a normal distribution. For example, let me write like this. Let us take bars also. Let me explain with the values only. So I'm taking some kind of bars like this. This value is 34, 34. Okay. And I'm going to take this side one more bar and this side with one more bar. And this bar is of 13.5 and this bar height is of 13.5. Okay. Again, so 68 plus 27, 95. So 95 plus this one. 2.25, 2.25. Okay. Assume this we are having like this. So 2.25 is nothing but probability. Okay, let me write in a probability way. 0.34 is the probability, 0.34. This one is having 0.135, 0.135 is the probability, 0.025 and 0.025. Okay, now it is symmetrical distribution. So left side and right side from the center value, if you see, the left side and right side both are same. If it is forming a symmetrical distribution, and if you consider the mu value here, that is the center value is mu. Now here, for example, you are considering the mu value of for example, in this class, the mu value is, I have kept an exam, some exam, average marks are 60 marks is the average mark, assume. After that, next number, what is the next number I am going to write? 70, 80, 90. This one, for our understanding purpose, actually we should not write that one. What number we have to write? The next one is with respect to mu plus 1 sigma. Standard deviation value. Whatever the standard deviation value is there, that standard deviation you have to add here. This second number is mu plus 2 sigma. This is mu plus 3 sigma. Left side is mu minus 3 sigma. Sorry, 1 sigma, mu minus 2 sigma, and mu minus 3 sigma. Assume the sigma value is 10 and mean value is 60. Now the next value is going to be the 70, 80 and 90. This is 50, 40, 30. Right? The second number, whatever you are going to write, is with plus 1 sigma. From this plus 2 sigma, plus 3 sigma, you have to write that numbers. The normal distribution is characterized based on the mu and sigma. Means the numbers are decided based on this. Now, if the data is forming the normal distribution, in that given data, 68% of the data will lie between plus or minus 1 sigma. 68%. If you add these two, it is 68. 0.34 plus 0.34, it is 68%. 68% of the data will be between plus or minus 1 sigma from the mean. 95% of the data will be between plus or minus 2 sigma. And 99.5% of the data will be between plus or minus 3 sigma. Sir, what is meant by this, sir? Okay, what is this? Assume that you're having one manufacturing company. Okay, yours is a manufacturing company. Okay, yours is a manufacturing company. In your manufacturing companies, you are manufacturing Kinley water bottles. Your company is Kinley. Assume your own company is Kinley. And inside this Kinley, you are manufacturing the water bottles. All the water bottles you are manufacturing. Multiple bottles you are manufacturing. Now, your company is a 2 sigma company. Assume that you are a 2 sigma company. 2 sigma company means 95% of the data will lie between plus or minus 2 sigma only. Whatever the mean value of the water bottle, for example, 1 liter water bottle is there. In 1 liter water bottle, for example, what is the average water will be there inside the 1 liter water bottle, you know? It is approximately, for example, 999, something like this. Plus or minus, some deviation will be there, some standard deviation will be there. That 95% of the bottles will be between this range only. Either it might be with respect to 1001 ml or it might be with respect to 998 ml. Not exactly 1000, perfect 1000 may not be. So it is going to be within the average value of plus or minus 2 sigma. 95% of the bottles will be within the mean plus or minus 2 sigma only. If, for example, if you are say 3 sigma company, or with respect to you're following a normal distribution, if it is a normal distribution only, this is all applicable. Okay, now it is 99.7% of the data will be plus or minus 3 sigma. 68% of the data will be plus or minus 1 sigma. Now, if your say 2 sigma company, now what is the meaning of 2 sigma company? Means, for example, this assume that Kinley water bottle is a 2 sigma company. It is a 2 sigma company. Assume it is a 2 sigma company. Now this Kinley water bottle 2 sigma company, it has to manufacture 95% of the data correctly. 5% error rate is accepted. Out of 100 bottles, 5 bottles, if errors are there, so you have to leave that one. For example, Kinla is a 2 Sigma company and you are a quality inspector. Now this time your role is quality inspector and you want to inspect the company and you want to see the bodies. In the bodies, whatever the sticker of 1 liter is there, they are maintaining the 1 liter or not. You want to inspect. Now what you have done is you have taken the 10 bodies randomly. Sample of 10 bodies you have taken. And in that you have observed that how many bodies are maintaining this one. If 95% of the bodies are perfect, means okay. If, for example, out of 100 bodies you have taken, 94 bodies are only satisfying the condition. 1 liter condition is satisfied only for 95 bodies. 1 body is missing. You are going to take the penalty. You will impose some kind of penalty. For example, only 80 bodies they are manufacturing perfectly. 20 bodies errors they are manufacturing and releasing into the market. You will close the company also. Because they are cheating now. So just based on the type of the company, if it is a 2 Sigma company, means their accuracy should be with 95%. If it is a 1 Sigma company, means their accuracy they can maintain up to 68%. If it is a 3 Sigma company, means 99.7% should be accurate. 99.7% means out of 1000 bodies, they have to maintain 997 bodies perfectly. 3 bodies only errors is possible. Sir, now you'll ask, sir, then who will apply for instead of 2 Sigma? Let us apply for 1 Sigma only, so that we can manufacture only 65% correct bodies and remaining we don't need to manufacture properly also. Na? But if you're not having with respect to 2 Sigma, the permissions will be different. The permissions will be different, the tax will be different, and the level will be different, and business also will be different. If you are a 3 Sigma company, miss, you are going to pay in a different tax. For example, for a 2 Sigma company, the tax you have to pay the tax of 10%. For 3 Sigma company, you have to pay the additional tax. So for, there is a, with respect to 1 Sigma companies, 2 Sigma, 3 Sigma, 4 Sigma, 5 Sigma, and 6 Sigma. Up to 6 Sigma we are having. 7 and 8, nothing is there. Only up to 6. 1 Sigma means 68% of the data. 2 Sigma means 95% of the data. 3 Sigma means 99.7% of the data. 4 means 99.97% of the data. 5 means 99.997% of the data. 6 Sigma means 99.99997% of the data. 5 and 7. Right? In India, we are having 6 Sigma company also. Some companies are there, out of which one of the companies Dabbawala, which is in the Mumbai. They'll manufacture with respect to some kind of dabbas. Okay, tiffin dabbas. So that particular company, out of 1 crore they manufacture and they release into the market. Out of 1 crore, only 3 defective pieces are allowed, but they'll not even allow that one. The quality is that much of high. Perfect accuracy they are maintaining. That is a 6 Sigma company. Right? To how much now IT industry, whatever the Infosys, Wipro and TCS, everything are there, right? All the IT companies are a 2 Sigma companies. So inside that we require 95% accuracy, 5% error also, okay, acceptable. Right? 95% of the data we should satisfy up to 6 Sigma. So now, for example, you are going to have in a university, you have measured the heights of the student. Okay. Now you have taken the data and it is following a normal distribution where the mean is 5.5 and standard deviation of 0.5. So mean of 5.5, standard deviation of like this. That is plus 1 Sigma, plus 2 Sigma, plus 3 Sigma, minus 1 Sigma, minus 2 Sigma, minus 3 Sigma. So in this university, 68% of the students lies between 5 to 6. Since they are forming the normal distribution, it is applicable only for normal distribution. It is not applicable for other type of distribution. For example, you are having like this right skew distribution, or you are having left skew distribution. It is not applicable. Only for normally distributed data, plus or minus 1 Sigma, 68% of the data. Within the plus or minus 2 Sigma, 95% of the data. Within plus or minus 3 Sigma, 99.7% of the data. Is that clear? This is called as 65, 95, 99.7 rule. Right? Now, this is the question in the TCS exam once again. Okay. Sir, why TCS exam is earlier I used to train on the TCS. That is the reason I have collected TCS exam questions. Right? Now here there is a normal distribution where we are having a standard deviation of 10. Approximately what area is there between 70 to 90? Now, can you tell me what is the area between 70 to 90? That is, they want this total is 95. Out of 70 to 90 means 47.5. So answer is 47.5 is the answer. Since it is a normal distribution, directly we are applying the rule of that. Okay, plus or minus 2 sigma, we know that total is 95. So right side is 47.5, left side is 47.5. Now, second question. Now this time you answer. What is the area between minus 2 to plus 1? From here to this one. Up to here. What is the area? Guys, what is the answer? From minus 2 to plus 0, what is the area? This is 47.5. From 0 to 1? From minus 1 to plus 1, it is 68. Obviously, from 0 to 1, it is 34. Now, if you combine these two, which is nothing but 81.5. This is 68 now. From minus 1 to plus 1, it is 68. Out of which you want the right side part, that is 0 to 1, which is 68. And from here to here, this is 47.5, this is 34. If you add total, it is 81.5. That's it. This is a basic question. Now, actual question. So here, if you're calculating from minus C, if you take the area, assume this is a normal distribution. Now, this is from here mu up to plus 1 sigma. What is the area up to plus 1 sigma means 34. Up to minus 1 sigma from here means 34. 34% and 34%. And from here to here, out of 47.5, 34, 13.5 is this one. This is 13.5. Okay. From minus 2 sigma, mu minus 1 sigma. If you take from minus 1 sigma to plus 1 sigma, it is 68. From minus 2 sigma to plus 2 sigma, it is 95. And now this part, whatever you are having is with respect to 2.5. So total is 95. 95 you already completed. 99.7 minus 95, which is 4.7. 4.7 divided by 2 sides, that is 2.35, 2.35. This is 2.35, this is 2.35. Total should be 99.7. Right? Minus 3 sigma to plus 3 sigma. Now, if I ask you a question from here to here, what is the answer? 68. Now, from here, starting point is same. From here to here, what is the answer? 81.5. Just you are adding everything. Now, if I ask you the question from here to here, what is the answer? The entire left side. Already this is 50% and plus 34. Total is 84. Now, if you are considering this one, the same thing from minus this, from starting point of this one to this one, 81.5. If you are considering from here to here only, miss 47.5, right? Now you can able to identify the areas easily with respect to up to 1 sigma or minus 2 sigma. But I want now the area from here to here, not exactly from this point or not this point. From here to here, I want the area. If I want to calculate like this, miss, it is difficult because you are not having with respect to of, don't take that out of 34 exact center point 17 will be there. Don't do all these calculations. Okay, example I have drawn randomly. You can't measure exactly, it is 0.65 or 0.5 now. So here, if you want to calculate from exactly from this point, from standard deviation to standard deviation, miss easy calculation. But in between any point, if you want to calculate, miss we can't calculate using this formula. So for that, what we are going to do is we are going to apply a different formula called as z-scores. So to calculate the area under the curve, we are using the z-scores. Z-scores are nothing but standardized values. You are going to apply the standardization. What is meant by standardization means each value minus mu divided by sigma. Each value, that is each value minus its mean divided by sigma, is called as z-score. Right? Z is nothing but x minus mu divided by sigma is called as z-score. Now, here, whatever you are having, x is nothing but observation, mu is nothing but mean, sigma is nothing but standard deviation. For each and every value corresponding z-scores, you are going to calculate. For example, you are having a normal distribution like this. Now tell me, for this data, what is the corresponding mu value? Center position, what is the center position? This is the center one, mu. What is the sigma? Don't see this one. After saying this one, you can easily say. Without saying that one, just from the graph. That is nothing but 10, right? So this is mu plus 1 sigma. Mu plus 1 sigma is equal to 70. Mu is equal to 60 means automatically sigma should be 10 only, right? So now you are having the 10 like this. Now these values you want to convert to corresponding z-scores. How you have to convert means first this value is there. This value minus mu. What is the mu? 60. What is the sigma? 10. That is nothing but minus 30 divided by 10, which is minus 3. So this will be minus 3. Now what is this value? 40. 40 minus 60 divided by 10, which is minus 20 by 10, minus 2. So this value is minus 2. This one with respect to minus 1. Because 50 minus 60, minus 10 divided by 10, minus 1. Next, this value, 60 minus 60, that is 0. 70 minus 60 plus 10 divided by 10, 1. 80 minus 60 divided by 10, which is 2. 90 minus 60 divided by 10, which is 3. So now corresponding each and every value are converting to the corresponding z-scores like this. This is a normal distribution. This is called as z distribution. This is called as z distribution because z-scores you are taking on the x-axis. This is called as z distribution, which is also called as standard normal distribution. This is also called as standard normal distribution. This is also normal distribution, but after applying the standardization process. Standard normal distribution. Standard normal distribution is equal to z distribution. Both are same. Standard normal distribution or z distribution. Converting each and every value to corresponding standard value. Standardize means corresponding z-scores, which is called as z distribution. Is that clear, guys? Now, after once converting like this, now if you want to calculate any area, for example, you want to calculate the area of this one up to here. Now, for this, we are going to have the z tables. So now you have to open the z table. So just open the z table, ztable.net. Okay. Z table. Right? We are going to have with respect to multiple z tables. Error establishing a database connection. Okay. Okay. These are the various values of z values. Now, whatever the z value you are having, this is the area. The right side, whatever the value is there, this is the area. So how to calculate from the z table the area? So let us take an example. Let me explain with an example. For example, you want to calculate the area under the 70. Can anyone tell me what is the answer? Forget about this one. This is not there. What is the answer of this? Up to here it is, this part is 50%. This is from here to here it is 34. Total is 84%, right? Which is nothing but 0.84. Now the same thing, how we can calculate means first, what is the question I asked you? What is the probability below the 70? I asked the question, What is the probability below 70? 70 means from here to here. What is the probability? This entire area I asked you. And you have given me the output as 84%, which is nothing but up to here 50% and remaining 34.84. Right? Now, what I am going to do is, this is a normal one. Now, the same thing, how I am going to do using the Z tables means this 70, number 70 is there. This first I will convert to the corresponding Z score. What is the corresponding Z score of 70? 1. Now, the probability of Z less than 1. Z less than 1. The same thing here. Both are equal, right? This one and this one both are equal. This is a normal number. This is a Z score number. Now, here, whatever the number is there, this number, go and check in the Z table. Whatever the number is there, whether it is a positive number means positive, negative number means negative. Just go and check in the Z table. So, what is the number is 1. So, 1 is with respect to 1.0, the answer is 0.8413. You can get directly like this. Got the point? For example, you have got Z value as 1.24 something, 1.243. You have got like this. So you have to take up to 2 digits, and out of which 1.2 you can see here, and 0.4 is another that you have to get from here. This is the value. The second digit is this one. This is the second digit. Whatever you are seeing here is the second digit. Up to 1 digit you can see here. If it is positive means positive, negative means negative. If it is positive means in the positive Z table you have to see. If it is negative means in the negative Z scores you have to see. For example, now tell me for the same example, once again in the PPT. Now what is the area under this one? What is the area? Forget about the Z scores. Just what is the area? Sorry? 16. Exactly. So up to here it is 50. 50 out of 34 you have to remove. Means balance is 16%. So it is nothing but 0.16. The same thing I am going to use in the Z distribution. That is nothing but I am going to draw a line up to -1. This is the area I want. Here the probability X is less than 50 is equal to here the probability of Z less than 1. That -1, less than -1. Now we will go to the Z table. In the Z table, what is the -1 score? 0.51, 0.1587, which is almost close to 0.16. Is that clear? So like this, you can get for any value. For example, in the same example, tell me what is the area under 54. If I ask this question, can you calculate here? It is not possible to calculate here, but it is possible to calculate here. Just this 54 you have to convert to corresponding Z score. That is 54 minus 60 divided by 10, which is nothing but minus 6 by 10, which is minus 0.6. Just open the Z table. Minus 0.6, what is the value? 0.2743, that is the answer. Now, in this way, we can calculate whatever the probability. Any probability you can calculate from the given data. Any point, any location you can calculate. But remember, always the Z table, whatever the output of the Z table is there, it is going to show you only on the left side area only, not the right side area. If you want the right side area, 1 minus you have to do. So, for example, I asked earlier the question, what is the area this side? And you have told me the answer as 84. And the same thing I have checked in the Z table, that is Z with respect to less than 1. And I have opened the Z table of Z is equal to 1 means I have got 0.84. Okay. Now I am asking you the question. I don't want with respect to less than this one. I want greater than this one. What is the answer? 16 only, right? So right side part is 16, right? Left side part is 84 means right side part is 16. Now how you have to calculate in the Z scores, you know, the same thing. First you have to calculate for 70. P of Z, you want greater than symbol, na? Greater than symbol of 1. Now 1 minus P of Z is less than 1. Which is nothing but this value is 0.884. 1 minus 0.84, that is 0.16. Whenever you want the right side area, you have to do 1 minus of. In the entire Z tables, you always gets the left side value. Sir, what is this Z table, sir? What is this calculation, sir? Miss, This is the basic statistics in order to calculate the probability without the data. Here I'm not having the data. There is no data with me. Without the data, I'm calculating the probability by seeing the only curve. Whenever the data is normally distributed only, you can apply this one. With data, directly you know the calculation. With data, how to calculate the probability, you already know. No need to explain that one. If the entire data was given and how to calculate the probability, just we are going to see how many values are satisfying the condition and divide by total number of points. That is very easy. Here the data is not there. What is the height of each bar is not there. What is the total number of data points they have collected is not there. None of the data is there. Just they have given directly the distribution is like this. Directly they have given the distribution like this. In the question, they will say directly only with respect to, we have collected the heights of the various students, where with this much, where we are having the mean value is this one, standard deviation is this one, means you have to write. For example, in my class, forget about the total number of students. I will not say what is the total number of students. I am not saying. And what is the each student marks also I will not say. For student 1, student 2, I am not saying any marks. I will say only one thing. The students are forming the normal distribution where the mean is, average mark is 70 and standard deviation is 5. Now, can you draw the normal distribution? Using these two values, can you draw the normal distribution? First, take the 70, 75, 80, 85, 90. Left side, 65, 60, 55, 50. Now, tell me, how many number of students are between 70 to 75? 34% of the data will be this one. Now, what is total number of students? You don't know, but you have told me the probability. Got the point? Is that clear, guys? So, if the data is normally distributed, means we can easily calculate the probability without the data points also. Right? So, by using the z-scores, we are able to calculate. In the certification, what they will do is, if for example, this is the question. So, this is the question. Suppose we have gathered the data from the last year final chemistry exam and followed it is a normal distribution with mean of 60 and standard deviation of 10. And what is the question is, what proportion of students are less than 49? This is the question. And for this question, they are not going to give us the statistics textbook. They will not send the statistics textbook. It is not BTech exam. Na? Just they will share us with respect to this kind of table in the certification. You will get a table like this. Inside this, one value is your answer. Inside this, one answer is there. Now, what you have to do is, first we have to calculate the for 49. So, for 49, whatever the 49 is there, for 49 you have to calculate and the area less than to that. So, first you have to convert that 49, whatever the 49 is there, that you have to convert to corresponding z-score. How to convert the corresponding z-score of 49 is 49 minus 60 divided by 10, which is nothing but minus 11 by 10 minus 1.1. Now, for minus 1.1, go to the z table. And in the z table, calculate the value, which is 0.1357. Now, whatever the value is there, it is left side area only. And you want also left side only. So, this is the direct answer. If right side answer you want miss, you have to do 1 minus. Left side area miss, directly take the answer, whatever the answer you are having here. So, z table always gives you the left side only. Whether it is a positive z score or negative z score also, always it is gives the, for example, you are having a positive z score miss. For example, this one is having a positive z score. This is the area. You will get the area like this. For this, you will get the area like this. For this, you will get the area like this. Always left side only. Whether it is a positive z score or negative z score also, for every z score, you are going to get the left side area only. Every z score, you will get the left side area only, not right side area. For right side area, you have to do 1 minus. In the given question, in the examination hall, if they have not given the table miss, they will give the Python option. In the Python, there is a formula for that, and you can write. 79 calculate. 79 minus 60 with respect to what is the answer? 79 minus 60, that is 19. 19 divided by 10 and 1.9. Here for 1.9, where is in the given table 1.9 is not there. Now up to 1.4 is the maximum. Sorry? Yes. 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 1 minus of. You can take. Is that clear? Now, for this question, now you please answer for this question, guys. What is the output of this one? And for this output, you have to open the Z table. Open your mobile phones, in the Google type the Z table, and you tell me the final answer. This is the question, and I want the answer. Fill in the blanks. There is no multiple choice. If you see others' notebook, miss, you'll never get a job. Feel that you'll never get a job. If you see others' notes, miss, you'll never get a job. Now it is of your choice. If you want to see, miss, enjoy. So here, while measuring the heights of the students at a local university, it was formed the normal distribution with a mean height of 5.5, 5.5 and a standard deviation of 0.5, that is 6.5. Left side is 5 and 4.5 and 4. Okay. And they're asking from 5.3, 5.81. Where is that 5.81? From here to 6.3 from here. So they want a normal distribution from here to here. This is the area they want. Now what I'm going to do is for first 5.81, I'm going to calculate the corresponding z-score. For 6.3, I'm going to calculate the corresponding z-score. For 5.81, the corresponding z-score is 5.81 minus what is the mean value? 5.5 divided by what is the standard deviation? 0.5. What is the answer? 0.62. Now for 6.3, 6.3 minus 5.5 divided by 0.5. What is the answer? 1.6. So they want a G of from 0.62 to 1.6. So now what I'm going to calculate is first Z of 0.62. I'm going to open the Z table with 0.62. Where is that 0.62? Positive 0.62. This is 0.6 and 2 is this one. That is 0.7324. Okay. Now for the second one, 0.63, 1.6. For 1.6, what is the z-score? 0.9452. This is the one. Right? Now For example, now I am having with respect to two values, two z values and corresponding probability values also I am having. Now, whatever this is the 5.81, this area, this entire area is with respect to 0.7324 it seems. Up to 6.3, the entire area, total area up to here it is 0.9452. Now I want in between area. That is 0.9452 minus 0.7324. This entire total area, you are removing this part. So what I am going to do is, for up to 5.81, I am going to mention in the color called as blue color. This is the area. The blue color area is 0.7324 is the blue color area. And this black color area includes the blue color automatically. Every area is included. The black color area is 0.9452. Okay, blue color is with respect to 0.7324 and this is 0.9452. Now I want with respect to the balance this one. I want with respect to the output of this area, which is this one. This area I want. So what I'm going to do within the entire black area, I'm removing the blue area. In the entire black area, whatever is there, in that blue area, if I remove, I will get this balance area. So the same thing I'm doing. Right? And you will get the answer. So from here to here, first you are going to calculate for 5.81, what is the answer? That is 0.62 and 1.6. From here to here you want, and you have calculated the z-scores and you are subtracted, and finally this is the output, which is 0.2128. That's it. Whoever has got this one perfectly, assume that you have understand the z-scores concept. Whoever has not got this answer, or who was struck off at the starting position, please revise once again. To load the data. Okay, this data set is called as tips data set. Okay, so this is a tips data set. Okay, so first I am going to import the pandas and pd.read CSV. CSV file is nothing but tips.csv. Okay, this is a tips data set where the waiter of a restaurant has collected this one. The waiter has collected for each person what is the total bill and what is the tip they have paid and who has paid, whether female has paid or whether the male has paid. Of course, more will be males only. Everyone knows, right? Now, whether the person was paid with female or male and smoker, whoever has paid the bill now, within that person is whether the smoker or non-smoker, and what is the day, Sunday or Wednesday or whatever the day, and what is the time, dinner or lunch or breakfast, whatever it is, and size, total how many has came. Means for this particular record, 2 people has came for the restaurant, out of which who has paid the bill is female has paid. Who is the second person? We don't know. Okay, don't ask. That is male or female, that is secondary. Here 2 persons has came, out of which who has paid the bill is female, and that female who has paid the bill, non-smoker, and they have visited on Sunday for the dinner time. This is the data they have collected. For this, we are doing the descriptive statistics. Descriptive statistics is only measure. Analysis part is called as exploratory data analysis. That is next class. In this class, I am going to do only the measures. I am going to calculate what is the mean value, what is the median value, what is the mode value, what is the range value, what is the standard deviation value. Values only I am going to calculate. Today, I am going to do only the measuring. I am not doing analysis. Analysis will be done in the next class with respect to exploratory data analysis. From this, what you have understand, what you are going to do with this data set, what you are going to predict in the future, that will be in the further class, right? Now, here, whatever the bill amount is the total bill. Let me clear the outputs. Import pandas as PD, and I'm reading the tips.csv file and I'm storing in the df data frame. And first we are going to start first one. What are the things we have discussed till now in the statistics? First, from where we have started, how many variables are, what is the type of variable? That is continuous variable and discrete variable. Within the discrete, nominal and ordinal. And this both comes under cross-sectional data. And apart from that, time series data. That is the first one. Followed by mean, median and mode. Then followed by range, standard variance and standard deviation. Followed by, we have calculated the percentage, quartiles. Based on the quartiles, we have calculated IQR, and based on the IQR, we have designed the box plot and calculated the outliers values. Calculation of outliers was done. Then after that, what is the next one we have done? Probability. We have calculated the probability and probability distributions. In the probability, we have seen with respect to what is probability, and in the probability distributions, we have seen with respect to discrete probability distribution and along with the continuous probability distribution. And we have calculated the correlation and covariance. And next, we have done with respect to calculation of z-scores, and using the z-scores, we have calculated the probability using the z-scores. Probability using z-score. So these are the things which we have covered in the statistics. Now everything we are going to see in the pandas. First, we are going to calculate the mean for a particular column, median. Before to that, first we have to identify how many are continuous variables and which are discrete variables. That we have to identify clearly. So here, first tell me whether it is a cross-sectional data or time series data. It is a cross-sectional data because this is not dependent on the time. There is no word of time and it is not dependent on the time. So it is a cross-sectional data, out of which this total bill is a, what type of variable this one? Continuous or discrete? It is a continuous. This one? Continuous. This one? Discrete categorical. This is a discrete categorical. This one? Again, discrete categorical. This one? Discrete categorical. This one? Discrete categorical. This one? This is also discrete count, where it is counting. Okay, just this is a count variable, but this is also a discrete variable. For this, all of them, you have to apply the discrete probability distributions or discrete concept of bar chart or pie chart. All these things you have to apply for this data. For these two columns, you have to apply with respect to histogram. For this column, you have to apply the histogram. For this, you have to apply the bar chart. Okay. So first you have to identify the variables. Now for continuous variable, for how to extract the single column using pandas? DF of that particular column, total bill. If I take this one, I will get the single column, right? Output of single column. For that single column, first I am accessing the single column. How to access a single column is like this, and you are getting the single column values. Now what you are going to do? Dot sum. You are just applying dot sum over that. What is meant by sum is summation of all the data points. Now mean means nothing but sum divided by total number of data points. The total, first you have to calculate the total number of data points. How to calculate the total number of data points? Len function, out of which len of df of total bill. You are doing the df of total bill, total underscore bill. And if you get 244, that is 4827.77 divided by 244, which is equal to 19.78. In this way, we can calculate the mean, right? Median. If you want to calculate median, dot median. Median is nothing but center value. Just it is going to give the center value. Minimum. What is the minimum value? In this entire data, whatever the minimum value is there, it is going to calculate the minimum value. Dot min gives you the minimum value. Dot max gives you the maximum value. Range is nothing but maximum minus minimum. That is nothing but 3.07, 50.8981 minus 3.07. It is the range. Maximum minus minimum. And you are going to get variance for that particular column, dot variance. If you apply dot variance, you are going to get the variance value. Dot standard deviation gives you the standard deviation value. And if you want to calculate the quartile, that is 25 percentile, if you want, miss, you write here dot quartile of 25. You will get the 25 percentile value. Similarly, this is the Q3 value. And IQR is nothing but Q3 minus Q1. That is this value minus this value. If you store into a variable, miss, the value will be stored. If you are not storing to a variable, miss, it will not be stored. If you are storing, like, for example, Q3 is equal to, you are storing. Now, what is the Q3 value, miss? You are going to get, this is the Q3 value. If you are storing this one as Q1, if you store, miss, it will store. Otherwise, it will not store. It is just printing. If you write, whenever you are writing the equal to only, it will store the values. So now you are having Q1 and Q3. IQR is nothing but Q3 minus Q1. Directly I am writing using the IQR is equal to Q3 minus Q1. Directly I will write like this. Now this is the IQR value. This minus this one. Right? Now whatever we have discussed, the mean value, median value and standard deviation, everything you can get in one shot by using the describe function. df.describe, for all the numerical data, by default it is going to select, this is the total number of values, and this is the mean value, this is the standard deviation, this is the minimum value, 25 percentile, 50 percentile, that is median value, 75 percentile and maximum value. You can get everything in one shot by using df.describe. That too for all the columns in a single shot. If you want for a particular column only, if you are interested for a particular column, you write for that particular column, total underscore bill. Then you'll get only for that particular column. This is the count. This is the mean value, standard deviation value, minimum value, maximum value, and 25 percentile, 50 percentile, 75 percentile. Whatever we have done in the above, the same thing you are going to get everything in a single shot by using the describe. Right? If you want the skewness, dot skew gives you the skewness, and here the value is positive, means it is a positive skewed. If the value is negative, means it is a negative skewed. If the value is 0, means perfectly normal distribution, symmetrical distribution. Right? Next, if you want the kurtosis, you can get the kurtosis. Similarly, covariance, you can select two columns, dot covariance. And correlation, you select the two columns and apply the correlation, and you will get the correlation between two variables. Right? Now, what I am going to do is, I am going to import pandas once again. So, once again, I am doing here, import pandas. Pandas.data frame where x is equal to 1, 2, 3, 4, 5, y is equal to 6, 7, 8, 9, 10. Okay, I'm going to create the data frame like this. Now tell me, for the first column, what is the minimum value? Column number 1, what is the minimum value? How to get that one? What is the code for that? df of that particular column name called as x dot min. If you ask min, miss, you will get the minimum value. What is the maximum value? You will get the maximum value. What is the average value for the x? What is the sum of the x values? Which is nothing but 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, 10 plus 5, 15. Sum is 15. What is the mean? Divide by 5, which is nothing but 3. Dot mean, 3. What is the median value? It is already in the sequential order only. Na? Median value is center position, which is 3. Is that clear? Simple data set. So for the simple data set, I have shown you, because in that data set, all the values you can't do the sum. Here you can do sum easily, right? So whenever you want to practice, see this one, generally you will expect, sir, can you open with a case study, sir, real-time example, sir? You'll ask like this. But whenever we want to learn, then this is the best one. Because each and everything we can do manual calculation, each and everything we can do with the Python coding. Whenever we want to learn, we have to go with a small data set. Whenever we want to apply, then we have to take a real-time case study. Directly, if you go with this one, directly if you select directly this one, Here, if you want to do the dot sum 4827, who knows answer? How you are going to calculate that one? You have to take all the numbers and you have to click on the calculator and click on everything. Nah? If you take like this, the small thing, you can easily calculate, right? So whenever you want to learn the things, miss, go with the simple examples. Don't take the complex examples. Don't confuse yourself. Don't think too much. So whenever you want to learn, first you fix yourself, whether you are learning or you are applying. When you are learning, miss, don't apply. When you are applying, miss, don't learn. With application, you want to learn simultaneously. Both the things I want to do simultaneously, miss, at the end answer will be the confusion. Why I'm explaining the statistics in a simple way? I'm saying everything is easy, dead easy, and this simple examples on the spot. I'm writing the examples why like this, because I have learned with respect to based on the simple examples. I was not confused myself by taking the complex example. I want to learn the mean, miss. Why I have to take this much of 100 data set only? Why with 1, 2, 3 I can't calculate mean? For 1, 2, 3 also mean is possible, right? 1 plus 2 plus 3, which is 6. 6 divided by 3, which is nothing but 2. What is the meaning of mean, miss? It is summation divided by n. So in my notes, I will write the formula. In my notes, I will write with respect to the theoretical. In my notes, I will write the calculation. In the same time, I will write in the pandas the code. Simultaneously, everything I will do simultaneously for a small example. For this example only, I will apply with the correlation quotient. Now here the correlation quotient is there with respect to you have got for this data set. The correlation quotient is 0.67. To calculate that one, you have to take the 244 values and you have to calculate the variance of that. Covariance of x comma y divided by sigma of x into sigma of y. That is standard deviation of x into standard deviation of y. When you will calculate all those things, if you calculate also, you will get the same value. So this is the covariance. Now covariance is 8.3. Now if you want with respect to correlation, what is meant by correlation? Correlation is nothing but covariance of x comma y divided by standard deviation of x and standard deviation of y. Covariance you have got with respect to 8.32. This is the covariance. Now, what is the standard deviation of x, miss? First, you calculate the standard deviation of x separately. What is the standard deviation of x is nothing but total bill. Total bill dot standard deviation, STD. Okay. Just calculate the standard deviation. Small l. Okay. So, what is this? DF of total bill. Key error. Total bill is not available. Why? TOTAL underscore bill. Oh, DF is now this one. Nah? Again, I have this one also. Earlier it is DF. Already I have executed DF. Now DF is this one. DF is having only x and y. So let me take for this one again. Once again, re-execute the DF first. Now DF is having with respect to this. Now DF of total bill will be accepted. Okay. And if you calculate the standard deviation, you have got. Similarly, similarly like this, you are going to calculate for the second one called as tip. Second column called as tip. Now, this is nothing but 8.32 divided by 8.90 into 1.38. Now just open the calculator. 8.90 into 1.38. That is denominator value is 12.28. 12.28 is the denominator and numerator is 8.32. So 8.32 divided by 12.28, which is nothing but 0.67, which is this one. Right? So the same thing, just it is doing in the back end, just it is calculating the covariance value, and for that it is applying this one. Right? For this formula, just it is applying that one divided by that one. Right? So if you are going with a large data set like this, it is difficult to calculate. Manually, it is difficult to calculate. Coding is easy. Code you can write by dot standard deviation, but who will do the manual calculation? Who will do the manual calculation? So whenever you want to do the manual calculation, go with a simple data set. Now for this data set, you can calculate the standard deviation of x. First, you can start with sum of x. You can do manually. You can do the mean of x. You can do median of x. You can do the range of x. You can do the variance of x. You can do the standard deviation of x. For each and every value you can do. You can calculate the Q1, Q2, Q3 separately. And you can calculate IQR manually. And you can see the simultaneously the code answer also. Both the things you are going to do the simultaneously. And in this way you can practice. Right? Whenever you want to learn means, go with a small data set. Don't go with a large amount of data set and don't get confused. Selecting the data set is also important.